Well, good morning, everyone. Thank you for coming. Today, I'm going to talk about making the right decisions in aviation. So this is what we're going to discuss today. First off, I have a brief overview of the NTSB, of kind of the makeup of our agency and how we work. Then I'll go into general aviation safety and accidents. Then we'll talk about aeronautical decision-making and risk. And then the majority of the presentation, I'm going to focus on different case studies related to accidents that I or my counterparts have investigated. So first off, who is the NTSB? Our job at the NTSB is to determine probable cause. We're mandated by Congress to do that, and to issue safety recommendations to prevent future accidents. So from my perspective, we all want to know what happened in the accident, but our biggest goal is preventing future accidents from occurring. So that's where we put our focus. All regional investigators are pilots, many are mechanics, engineers, and have varied aviation backgrounds as well. So we want to find out what happened to prevent them from happening again. Now, we are a multimodal agency. We do aviation, highway, marine, railroad, pipeline, and also hazmat. We're also very small. We're about 450 people. Office of Aviation Safety is about 150, and as far as regional investigators, we have about 50. So we're small, limited resources, but we work with different manufacturers as well as the FAA in accomplishing our mission of determining probable cause and preventing future accidents. So these are some accident numbers from 2010. In 2010, we had 1,435 GA accidents, 267 fatal accidents, resulting in 450 fatalities. Now, because of these numbers, the NTSB has been working with the FAA as well as various pilot user groups and aviation interest groups to improve the GA accident rate. And no one wants more regulation, right? So how we can do this is through better risk management and aeronautical decision-making, that we can take the tools that we already should have in our flight bags and use them to be safer pilots. So as I'm talking through these accidents, it's good to think about what kind of pilots are considered accident pilots. What do we think of that? What do we think an accident pilot is? And what quality do you think they might have in common? And the simple answer is we're all human, right? We're all capable of making mistakes and doing these types of things. So what we can learn is when we're going through the case studies is to say, how could I, in a similar situation or circumstance, make these same mistakes, and how can I prevent myself from doing that and become a safer pilot? So many of the accidents that we investigate involve a chain of events, and I'm sure you've all heard, that error chain keeps connecting the links, and if we break that chain, then normally we can prevent the accident. And the problem that we come across is recognizing that we have this chain of events occurring, that they found in different research that when you're involved in these type of situations, sometimes it can be difficult to recognize how far into the chain of events you are and that you're actually putting yourself in a position you may not want to be in. So by considering these risks before we leave the ground, it really helps mitigate them. So you've all seen this definition in your pilot training, what aeronautical decision-making is: a systemic approach to the mental process used by pilots to consistently determine the best course of action in response to a given set of circumstances. And in order to perform aeronautical decision-making, we anticipate, we recognize, we act, and we evaluate. So we should be constantly going through this process as both in our flight planning and in the air. Now, risk is exposure to the chance of injury or loss, a hazard or dangerous chance. And our levels of risk in flying are dependent upon the nature of flying. So if I'm going out on a VFR day, my risks are going to be different than they are on an IFR day. If I'm flying a new aircraft that I don't have a lot of time in, those risks are going to be a lot different than if I've flown an airplane that I have maybe 500 hours in and feel very comfortable in. Also, the type of equipment, if you're flying a low-performance airplane as compared to high performance. So considering all these things is helpful in assessing where the risk lies in the flight. So when we're looking at risk, we can look at these 4 variables. And there are other things that you can look at, but during my presentation today, I'd like to focus on these 4. There's various checklists out there that use these 4, and they're easy to remember. So we're going to look at pilot, aircraft, environment, and external pressures. So when we're looking at ourselves as pilots, we look at what is our experience. Have we been flying lately? Have we not been flying lately? Has it been a long winter? I live in Montana, so sometimes we have 2 months of snow and no visibility, but then we'll have a great, beautiful winter, clear blue day with perfect performance, and so you want to go flying. So as opposed to the summer where you might be flying every day. So you look at your experience. You also look at the conditions for the flight, what type of weather is available, and also what kind of terrain are you operating in. Are you going to be in controlled airspace or uncontrolled? Now we look at the aircraft. We talk about fueling systems and understanding fueling systems, and actually one of the case studies I have will talk about that because, as you all know, running out of fuel continues to be one of the common causes of accidents. Also understanding the performance on your aircraft. So if you're going into a different airport and you aren't familiar with your airplane's performance at different elevations and things like that, you need to either get an instructor to assist you or get into the POH and understand that. Also looking at emergency equipment. If you're flying in a well-populated area or over mountainous terrain, your emergency equipment requirements may be different. Also systems knowledge. That can vary, and dependent upon the flight or the emergency you encounter, you need to understand the systems. And that would include avionics as well. Environment includes such things as weather, airport conditions, and also terrain. If I'm operating at sea level and then I go up to 7,000 feet, what are the considerations that I need to take into account before departing on this flight? And finally, we look at external pressures. So am I just going out for a local flight, or am I going out on a family reunion where it's necessary that I be there, or am I going for a business meeting? So all of these things gauge in different levels of risk in how you're going to assess the flight. Do you have an alternate plan? If you need to divert, how will you do that? And finally, what personal equipment do you have on board that might help with these external pressures during the flight? So I'm going to go through the case studies now, and as I'm going through here, what I'd like for you to think about and what I'd like for us to discuss a little bit on each of these is what's the decision-making involved in each of these accidents, and what were the risks involved? And then finally, how could we prevent future accidents of this type from occurring? So that's kind of where we can really learn from these accidents. And I present these accidents never to associate blame with those involved, but to learn, right? That I think throughout all of this, we just need to remember that we're all human and we're all capable of making mistakes. So this first case study involved fuel exhaustion, and we had a Cessna 180. He was returning from the backcountry and flying kind of over remote terrain, and it was a Part 91 flight, and engine lost power, and he force landed the airplane in mountainous terrain. And we had 2 minor injuries in the front seat and 1 serious back injury in the back seat. And the serious injury in the back has since recovered. So our pilot was a private pilot, and he has about 824 hours and 274 in the make and model of the airplane. So he was familiar with the airplane. He had flown it quite a bit. He had done this trip before and was familiar with the route of flight and with his aircraft. Now, the aircraft itself we took a look at, and all the inspections were current on the aircraft. And we started looking into the fueling history of the aircraft because there was a little confusion about the amount of fuel that should have been on board when the engine lost power. And we did have an Oregon State Trooper that responded to the accident site, who was actually a pilot himself, and was able to provide us useful information about the quantity of the fuel and positions of things on scene. So this aircraft was originally equipped with 30-gallon fuel tanks. And in the early 1990s, it had been modified with 28.2-gallon fuel tanks through the Supplemental type certificate process. And when the pilot purchased the airplane from the previous owner, he was told that all of the fuel was usable, so that 56.4 gallons were usable. And when we researched the STC on the aircraft, it indicated that 51.4 gallons were usable. So that was a pretty big difference. And with this particular flight, because he was coming back from the backcountry, there was a limited fuel reserve made. And this STC also required that there be placards on the fuel selector and tanks indicating the fuel quantities and usable fuel. So we talked about the external pressures to complete the flight, and pilot reported no pressures to complete. This was just a leisurely trip with his friends and was returning. And he did indicate on prior flights along the same route that he had refueled. So he hadn't flown the aircraft for this extended amount of time without refueling. Now, this was a cross-country personal flight, and it was a flight over the wilderness. And one of the things we see a lot in aircraft, finding aircraft these days, a lot of people are carrying those spot devices or similar devices that track your position. And in this particular case, the pilot, the folks that he was with camping, they accidentally swapped spots. And so when the aircraft crashed, his friends' emergency notifications were notified instead of the pilot's. Now, a rescue was underway either way, but it did cause a little confusion. So just a little reminder, don't swap your GPS device because the wrong people will be notified and it may extend the recovery. Okay, so here's a photo of the aircraft, and this is right after it landed, and you can see here that the folks in the front seat were very fortunate in just sustaining minor injuries. So part of our investigation included looking at the aircraft itself and understanding whether or not we had a mechanical issue. Now, the other thing we wanted to look at was verification of the STC placards. We knew what it said in the book, what was supposed to be on this aircraft, but was that indeed what was on the aircraft? So here's a photo of the fuel selector, and you can see it does say 51.4 gallons, which was required by the STC. We also had placards on the fuel tanks that were consistent with the STC. So in looking at this accident, what types of decisions or risk factors were in place before the flight departed or during the flight that could have been taken into consideration to prevent the accident from occurring? He should have researched the aircraft a little better and understood the amount of fuel that it it could carry. And so, I think that's a lesson for us all, especially if we're buying used aircraft or flying rental aircraft, that someone can tell us something, but it's important that we go out and verify that information as well. Provide for a greater fuel margin during your flights. So if you are, he had done so on previous flights and completed them successfully. So again, if that would have been done in this flight, he was just 10 miles from the destination airport and likely would have landed successfully. Okay, well, let's move on to the next accident then. And this next case study involves a flight into instrument meteorological conditions and is a common accident type involving fatal injury. So when we look at the fatal injury number of our accident data, a lot of them come from this area. So this involved a Part 91 flight, personal local flight, and a Piper PA-28, and both occupants on board were injured, were fatally injured. They were going from their children's house back to their home airport, and this was over on the West Coast, and essentially involved, it was flat terrain, but there was a group of hills separating the departure airport and arrival airport. And it was VFR weather at both airports, although there was a layer of fog along the hills in between the two. And this was a common flight that this pilot had completed in the past, and that they had done this quite a bit. So our pilot was a private pilot with no instrument rating. The passenger was also a pilot, but no longer flew. And when they departed, it was a day VFR flight. Their kids reported that they were rested for the flight, and the pilot had flown about 3 hours in the past 90 days. The aircraft itself, all of the inspections were current. The pilot and passenger had owned this aircraft since it was new, so they had owned it since the 1970s, and were very familiar with the aircraft, its systems, and speaking with the mechanics that had worked on the aircraft, it was very well maintained, and they did a good job taking care of it. And during the flight, the pilot requested VFR navigation and also flight following. In speaking with the family members of the pilot, they reported that they needed to return to their home airport for an afternoon meeting. And they weren't sure what the purpose of this meeting was, but that's what they were getting back for. So we had this scheduled meeting going on. Now the environment, this was a familiar route. They had flown it many times in the past, and no weather briefing was obtained. The route, as I mentioned, crossed over hilly terrain that had low fog covering the hills. And in the weather briefing that we obtained following the accident, we had precipitation also along the route. So here is a straight line distance between the two airports. They had departed from Auburn, California, and were going to San Carlos. And the main wreckage there is down in the hills. And I'll be showing you a cutout of the radar data that will focus kind of on this area here. So this upper area here. So here's the radar track, and you can see that they're generally flying northeast to southwest, and then once reaching that hilly terrain, start flying along it there. And here's a close-up of the radar data and the last radar point we were able to obtain. And this is an overview of the wreckage. So we had the direction of impact was going to the southeast, and we have these initial impact points where the trees followed by the wings. And then we had ground markings leading up to the main wreckage, and then the engine was just forward of that. And it's difficult to tell on this photograph, but this is actually slopes upward a little bit, and then this is goes downhill here. Many times when we have accidents that occur in IMC, we arrive at the accident site on a sunny day because the storms have passed through. In this particular case, we had the same weather system passing through. So witnesses reported ground fog coming and going, you know, with very nice conditions above that, but that coastal fog that moves in and out continued the day we were on the accident site. So this is a view looking west, and these were the initial trees that were impacted, and then the debris flowing this way. And then this is looking downhill. And this is the main wreckage there. And you can see the majority of the wreckage was torn away as the aircraft went up and then down this hill. So in looking at what we know about this accident and about, you know, the background of the operational characteristics of this pilot and the flight, what are some of the decisions and risk factors that we might consider, or how could we prevent something like this happening again? Get a weather briefing. Instrument training. So if you're operating in an area that is frequented by IMC conditions, perhaps get instrument training, or at least maybe go out and get some hood time, right? Now the question was, did the pilot know what the tops were? And we don't have an indication of that because there was no weather briefing. So other than visually knowing where they were based on previous operation in that area, we don't know. Right, and I think the comment was there with the 3 hours in the last 90 days, it doesn't seem like a lot of time. And I think because they had owned this aircraft for so long, they knew the system. So, but yeah, we do want to fly as much as we can to maintain our currency. Have a plan. If you do encounter weather during your flight, what will you do? Will you return to your departure airport? Are there other diversion airports along the way? Plan ahead, and that makes it easier to make that decision once you encounter that weather, right? As opposed to trying to fly and make the decision at the same time. So this next one involves a controlled flight into terrain, and this was an instructional solo flight. The purpose was a cross-country in preparation for this pilot's commercial pilot certificate, and a Piper PA-28, and the pilot just sustained minor injuries. So we received this notification that we had a missing aircraft in eastern Montana, and eastern Montana is relatively flat. There are a couple of mountains out there, a couple of ranges, and this flight was at night. They initiated the search, but they did not find the wreckage or the pilot that evening. The following morning, the pilot contacted his flight instructor and said he was okay and gave his approximate position based on what he knew. And he was rescued shortly thereafter. Now, the flight itself, this private pilot had originally started flying in the state of Washington and had moved to Montana where he had completed his instrument rating. So the majority of his flight time in Montana was working on this instrument rating, and he was healthy and rested for the flight. Airplane itself was a new Piper. All the inspections were current, and it was equipped with advanced avionics. So we had 2 Garmin 430s on the aircraft, and then the Avidyne MFD and PFD system. So as well, of course, as all of your other instrumentation on board the aircraft. And The purpose of this flight was not to use those advanced avionics. You could use them to assist, but it was to conduct VFR navigation, pilotage, dead reckoning, the things you do on a commercial night cross-country. Pilot reported no pressures to complete the flight. This was a training flight, but he could have done it any time. He wasn't under any sort of time schedule. So our environment, as I mentioned, this area is generally flat, and we do have a small mountain range, the prior mountain range, east of the route. And so the flight instructor, in reviewing the student's flight plan, verified that these night checkpoints would have been visual, because sometimes we can pick out checkpoints, and if they're not lit, then they're really not going to do us much good at night, right? So she verified that, and pilot did obtain a weather briefing, and it did call for mountain obscuration over along these mountains in the area. But his intended route of flight was not to go in that area, so it was not pertinent to his planned route of flight. So here is the information from the avionics on board the aircraft. Now, the departure airport is right around here, and he was, it's a tower-controlled airport, and he was vectored out into this area and then started his VFR navigation according to his flight plan, and actually input the course directly into the GPS and flew it that way. Now, his planned route of flight was to go over here, and this is a big open flat prairie. And so he intended to go over here and down into his destination airport. So we had to try to determine how he ended up over here in those mountains. And there's just another close-up of the accident site and the destination. So we talked with the pilot about his actions during the flight and kind of how he used the avionics on board, and did he use the ground checkpoints. And what he had indicated is that he did use his flight planning data, but he did not look at the ground checkpoints that he had planned. And so when he was out of the controlled airspace, he input his course into the avionics on board the aircraft and put the autopilot on and had the autopilot fly the aircraft. And we also asked about the terrain information, that is displayed within the cockpit, and he actually did not have that information displayed, but had engine data. He did have some on the Garmin 430s, but not everything up and running. Now, as he approached the terrain, he did get warnings on the GPS, the red X's that he was approaching terrain, and he also was encountering snow. And right at the last moments, he pulled up and impacted terrain shortly thereafter. This is a view looking from the accident site back towards the departure airport. Okay, so this is taken from a Super Cub mountain rescue aircraft that conducts the searches in Montana. And our accident site is right in this area here. So you can see you can't really see the accident site in this photo, is why I'm showing you this. Just the difficulty in seeing a white aircraft in snow-covered terrain. It's difficult to find. And here's a picture of the aircraft. Now, after the aircraft crashed, the pilot spent the night in the aircraft. So he assessed, he knew that if he wandered away from the aircraft at night, he knew that the survival aspects were very low. And so he did spend the night in the aircraft, and this is what the cockpit looked like. So after the aircraft impacted the terrain, the pilot made some critical decisions and that helped to save his life. Now, Montana has a winter survival course. I don't know if you've all seen the recent article in AOPA. One of their reporters went up there and took the course. And you get to go out and spend the night in the wilderness, and you can sleep in an airplane fuselage. You can build your own tent with branches. You can, try to see what you would do in a similar circumstance. So it's kind of preparing before you end up in a situation like this. But this pilot had taken this survival course, and so after he crashed, he assessed the resources that he had. He did have a survival kit. He knew he needed shelter. And one of the critical pieces of the survival course was making yourself visible. Because when you're down there within the trees and terrain, you're essentially invisible. And you can see right up in this corner, the aircraft had an orange tarp on board, and that's what the pilot used to signal to the overflying aircraft where he was. So they were able to hone in on him, and then once they got into that area, were able to find him. So looking at this accident, how could this have been prevented? And what are some of the risk factors involved in decision-making that went on? When he did his flight planning, he didn't account for the positioning by the air traffic control. So he did his flight planning based on leaving from the airport. And by the time he entered his course into the GPS, he was in a different position from where his flight had planned. Okay, the comment was it appears that he didn't need to refer to a chart or see what the highest terrain was in the area. And in speaking with him, it sounded like he put a lot of weight on the avionics on board the aircraft. So once that course was typed in, the autopilot was set, and then not a lot of monitoring of position like you would normally do on a piloted or dead reckoning flight was happening. We have these aircraft with these advanced avionics and all this equipment on board, but because this equipment does make flying a lot easier, we tend to shy away from the previous basic piloting skills and pilotage and navigation, and it's important that we keep those current and use all of our tools instead of just one. So, good comment. Even with the warnings, he did not pay enough attention to the warnings he was getting. So again, this goes back to our systems knowledge and understanding what we have, what we're seeing, and processing that data. I don't know, we've all, those of us who have used the advanced avionics, you get into there and you start typing in things, and sometimes it's like your home computer and it says something that you didn't really want it to say. So practicing with that on the ground and understanding that is very helpful. The question was how much of a factor was the weather that he encountered. And the snow was a snow flurry, so he noticed it and he was responding to it, but it really wasn't a factor in the visibility because he wasn't monitoring his position anyway. It was such a dark night that it really wasn't a factor anyway. It was a light snow flurry, so it wasn't a heavy wet snow where it would have affected the performance on the aircraft or something like that. The question was he still on autopilot or hand flying the aircraft? And in those last moments, he did indicate once he was receiving the terrain warnings that he did manually control the aircraft and see that he needed to gain altitude very quickly. Yeah, the comment was it was great he went to the survival school, and yes, we agree that understanding the visibility requirements, notifying people if you can. He was very fortunate to have cell service out there and able to contact his instructor and staying with the aircraft. He also shot off flares during the night. The search and rescue teams did not see those flares, but yes, so that was good. And you never know when training like that can assist in helping you do these types of things. So this will be the last case study that I'll go over, and it also involves a supplemental type certificate. And I think it's useful for those of us that rent aircraft, or also if you're installing an STC on your aircraft, on your own personal aircraft. So this was a Part 91 flight and involved a Schweitzer 269 Charlie helicopter, and the student pilot sustained serious injuries. So our initial information was that the pilot had departed, and once obtaining his cruise altitude for this flight, he applied the heater, and shortly thereafter, the engine lost power. He conducted an auto rotation and landed. So as I mentioned, this was a student pilot. Days solo cross country. He was healthy and rested for the flight. The helicopter itself, all the inspections were current, and the helicopter did have an STC installation for heater control. And the company had another helicopter that had a heater installed opposite from the accident helicopter design, and I'll show you some photos of the cockpit of both of these helicopters. But based on this, the fuel shutoff controls were also designed opposite. And in the accident helicopter, the pilot sat on the left, and in this other company helicopter that he had flown, he sat on the right. So an accident helicopter, he's sitting on the right. The fuel control is a push-pull type knob that's closest to him on the panel, and then across on the other side of the panel would be the heater control. And the other flight school helicopter, he's sitting on the right. It's a push-pull control for the fuel shutoff valve closest to him, and then farther away you have the heater control. Same type of knobs. Pilot reported no pressures to complete the flight, and this was a routine cross-country. He had done it before with an instructor, and was not any difficulties encountered for the actual flight planning portion. So here's a photo of the helicopter after the landing, and you can see that the touchdown was pretty hard with the buckling of the skids and all that had occurred. So here's a picture of the panel of the accident helicopter. So pilot's on the left, and we have this knob here where showing the fuel shutoff control and the cabin heat control. And what you may have come to the conclusion already is that when the FAA actually went out on scene initially for us on this one, this knob was pulled instead of the heater control. Now the other company helicopter, you can see you're over here, and we have exact opposite design. So in this case, what could you do as a pilot to prevent this sort of thing from occurring, and how could this accident have been prevented? Okay, the comment was undo the last thing you did. So if your engine loses power, push the heat back off, right? Okay. In this case, I think he was pretty low, so he, as a student pilot, he was trained to go into an auto rotation, but yes. Okay, back to the flight school. So have flight schools consider not switching new students, probably especially, back and forth between aircraft that have these sorts of design considerations. Okay, the comment was the knobs are very similar, size, color, design. Make them dissimilar so that maybe one is not a pull type knob, that it's activated differently, or has a guard or something like that. Okay, so have some sort of spring engagement, so you have both a different feel, and you might not necessarily have to look at it. You touch it and know what you're doing. All right, good. Those are all good comments. Okay, so just to kind of review what we've gone over, fundamental risk management is as important as good stick and rudder skills. And many risks that we encounter during the flight can be evaluated before we leave the ground. And by considering these risks now, we allow for easier decision-making later. So If we're not encountering the weather, if we're not encountering an emergency, if we're not doing those sorts of things, then we can have already made the decision to divert, have already made the decision to enact our plan so that we don't need to be doing that in the air. Also, understanding our personal limitations. Know the weather on the ground and in the air, and understand your aircraft, especially used aircraft with lots of different modifications. Just because you have the POH doesn't mean you have all of the information on the systems of the aircraft. They can have been highly modified, and unless you read the supplements, you don't know that. Also recognize the external pressures that we put on ourselves in flying and doing these sorts of things. And then finally, practice skills through instruction and online resources. There are numerous pilot groups that offer great free training online. And we can do risk assessment checklists just to remind ourselves of the things that we should be thinking about before we depart on a flight. So thank you very much for your attendance and your participation. This is very fun for me, and enjoy the rest of the show.